This video looks at a couple of past paper questions on velocity time graphs. Pause the video and have a read through this question. Give yourself 2 or 3 minutes to answer the question and then press play when you're ready. Okay, these questions are about velocity time graphs, so we need to be careful not to model them up with distance time graphs. Part 1 asks us to describe the motion of the racing car during period W. And as we can see here in the first 2 seconds here, then the velocity is increasing at a steady rate. So we have got constant acceleration. There's only one mark here, so just writing acceleration would get you that mark. Then it asks us to say what's going on in period Y. Be very careful here, this isn't stationary. We're at a constant velocity of 50 meters per second. So we need to say constant velocity. Okay, pause the video to have a look at the next part of the question. There's 4 marks available, so give yourself 3 or 4 minutes to answer the question and then press play when you're ready. Okay, in this question then we're asked to calculate acceleration. And remember that on a velocity time graph, acceleration is going to be the gradient. We're looking at period X, so we're going from here to here. Now there are 2 ways you can answer this question, both of which would be correct. The first way could be to use the equation that acceleration is the change in velocity divided by time, v minus u over t. If we do that, then we look at the final velocity at the end of section X, which is 50 meters per second, and we look at the initial velocity at the beginning of section X, which is 10. So the acceleration is going to equal 50 minus 10 on the top, and then we need to divide by the time. Well, the time goes from 2 seconds to 6 seconds, so that's 4 seconds. That will give us 40 divided by 4, which will give us an answer of 10 meters per second squared. I'll come back to the units in a moment. Or if we want to, we could use the gradient of the graph instead. So I could draw a nice big triangle. Remember, do exactly the same as you do in your maths lessons. The biggest triangle you can manage, and then we're going to do change in y divided by change in x. Of course, it's going to give us the same answer. So the change in y then is from 50 to 10, so 50 minus 10 equals 40, and the change in x is going to be 6 minus 2 equals 4, and of course the gradient then is the change in y divided by the change in x. So we've got 40 divided by 4, which of course still equals 10, and we mustn't forget the units meters per second squared. There's 4 marks here, so they are expecting you to show clear working out and the units to get full marks. Either method is fine though. Okay, pause the video to have a read through question 2. Give yourself about 4 or 5 minutes, and when you're ready, press play. Okay, part A asks us to find the total time for which the velocity of the runner is increasing. And this question is really asking, can you read the graph correctly and not fall into any daft traps? So let's see where the velocity is increasing. Well, it's increasing in this section here. Okay, then it increases again in this section here. Don't fall into the trap of thinking the answer is 10 seconds, because we have a section here where the velocity isn't increasing, the velocity is remaining constant. So we're going to ignore that bit there. Okay, so we've got 0 seconds here, and it increases up to this point here, which is 4 seconds. It then starts again at this point here, which is 7 seconds, and continues to increase until we get to 10 seconds. So we've got 4 seconds along here where it's increasing, and another 3 here. So the 2 marks are for spotting that, and noticing that obviously 4 plus 3 gives us 7 seconds. Part B then asks us to determine the deceleration of the runner. That's important, is the deceleration. So we now need to find the section of the graph where deceleration is occurring, and of course it's this last section here where the velocity goes down. And again, to find the deceleration of the graph, we need to find the change in velocity divided by time or the gradient. Either method would be fine. Either way, we're starting at this point here, and that's at a velocity of 2, and at this point here we've got a velocity of 0. So if I were to do this as a gradient, I'm just going to draw that in, sorry about the wobbly line, then the change in velocity, or the change in y in this case, is going to be 2 minus 0 equals 0. And then the change along the x-axis, or the change in time, slightly harder to see on my wobbly line here, but it goes from 14 seconds to 24 here. It's going to be 24 minus 14 will give us 10. So if we do it by the gradient method, then I've got change in y divided by change in x gives me 2 divided by 10 equals 0.2 meters per second squared, and they've given us the unit. If we looked at change in velocity divided by change in time, then the change in velocity is still 2 and the change in time is still 10.